Okay, so for today's video lesson is the second half of topic 1.4. We're going to be doing the surface areas of right cones. Okay. So a right cone, this is a 3D object that has a circular base. And a curved surface. Okay, so again, the height of the cone, similar to right angle pyramids. This is the perpendicular distance from the center of the base to the apex. Okay, before I go any further, I'm just going to go ahead and draw a cone here. Okay, so my height, again, is from the center of the base, forms a right angle, and goes to the apex. Okay, so this is my height. And the slant height of the cone is going to be right there. Okay, so this is the shortest distance on the curved surface so it's the shortest distance on the curved surface between the apex and a point on the circumference of the base. Okay, so that is right here. And that is my slant height. All right. So just some terminology there that you are expected to be familiar with. Okay. So again, like we did last lesson, there are some formulas that we're going to be using here and going forward. Some of these formulas might look familiar to you. So area of a circle, area is equal to pi r squared. Okay. Remember, if that's a general circle, from the middle to the outside is the radius, and the whole distance across is the diameter. And remember, the circumference goes all the way around the circle. Okay, so circumference of a circle. So circumference is equal to pi times the diameter of the circle, or circumference is equal to 2 pi r. Okay. And now we're going to drive a formula for the surface area of a right cone. And this is going to be similar to the perimeter, or to the formula that we used in the last lesson. Okay, so surface area is equal to slant height divided by 2 multiplied by the perimeter of the base plus the base area. Okay, so surface area, we're going to leave slant height over 2 alone. And in this case, the perimeter of a cone is going to be a circle. So the perimeter is going to be circumference, which is 2 pi r plus the base area. Okay, I can simplify this. So divide by 2, multiply by 2. Those will cancel. Now I have surface area is equal to side length or slant height times pi times the radius plus the base area, which is a circle. So we can use that formula right up at the top. A is equal to pi r squared. So it's slant height times pi times r plus pi r squared. Okay. So this is our lateral area. And this right here is our base area. So similar to the formula that we used yesterday, surface area for a right angle pyramid or a right angle cone is still going to be the lateral area plus the base area. All right, so let's get into an example here. So a right cone has a base radius of 2 feet and a height of 7 feet. So let's go ahead and draw this. So it has a radius of 2 feet and a height equal to 7 feet. We are to calculate the surface area of the cone to the nearest square foot. Okay, so I know my height and I know my radius, but I do not know the slant height. So let's start there. Okay, so hopefully you can see we kind of have a right angle triangle right here. Okay, so the dimensions of that, we know it's 7 feet tall, it's 2 feet wide, and we don't know the slant height, okay? But this is a right angle triangle, so we can use our Pythagorean theorem. A squared plus b squared is equal to the hypotenuse squared, which is my slant height. Okay, I'm going to isolate for slant height. So slant height is equal to the square root of a squared plus b squared. Again, what we label as a or b, it doesn't really matter as long as we have the hypotenuse equaling the sums of those. Okay, so slant height is equal to the square root of 2 squared plus 7 squared, which is equal to root 53. Okay, I'm going to leave it as a radical, root 53, because that is an exact answer. Okay, so now we know our slant height is root 53. Now let's go ahead and find the surface area of the cone using the formula we talked about on the last slide. Okay, so surface area of a cone is equal to pi times the radius times the slant height plus pi r squared. Okay, so let's just go ahead and substitute this. So surface area of cone is equal to pi times the radius, which is 2 feet, times the slant height, which is root 53 feet, plus the base area, which is pi times radius, 2 feet squared. Okay, punch all those into your calculator. We'll get a surface area of the cone equal to 58.30 and a bunch of decimal answers there. Units on that is square feet. Question is asking us to round it to the nearest square foot. So I'm going to look right here. It's 4 or less, let it rest. So surface area of the cone is equal to 58 square feet. All right. Last one for today's lesson. Okay. So we know the lateral area is equal to 220 square centimeters. The diameter of the cone is equal to 10 centimeters. And the radius is half of the diameter. So diameter divided by 2 is equal to 5 centimeters. Okay. So this is just what we have been given in the question. So let's go about solving it now. So determine the height of the cone to the nearest tenth of a centimeter. Okay. We know from our last couple slides that the formula for surface area of the cone is equal to pi rs plus pi r squared. Okay, so we're looking for the height of the cone. So I'm just going to draw a picture here. So we know the radius is 5. We need to find the height of the cone. Okay, so which part of this formula is related to the height? Right here. If we know the slant height and we know the radius, we can go ahead and find the slant height using the Pythagorean theorem. Okay, so that's what we're going to do. Okay, so let's go ahead and fill in this formula with what we know so far. Okay, so surface area of the lateral area, which is what we know. So this is our lateral area. Okay, so surface area of the lateral area is 220 square centimeters is equal to pi times the radius, which is 5 centimeters, times the slant height, which we are looking for. Okay, so we're going to divide both sides by pi times 5 centimeters. Those will cancel. Okay, from there we get our slant height equal to 14.005 centimeters. Okay, so that is our slant height. Now we need to find the actual height, right? So this is 14.005 centimeters. We know our radius is 5 centimeters as well. And now we're looking for our slant height. Okay, this is a right angle triangle. So because it's a right angle triangle, we can use the Pythagorean theorem. A squared plus B squared is C squared. So this is going to be A, this is going to be B, this is C. Okay, C is always across from the right angle. And I want to isolate for A. So I'm going to subtract B squared from both sides and take the square root. So A is equal to the square root of C squared minus B squared. A is equal to the square root of 14.005 squared minus 5 squared. Okay, punch those into your calculator. We will get a value, which is our height of 13.08 centimeters. And we're rounding it to the nearest tenth. So we look to the right of it, it's 5 or more. So we will raise the score. So final answer, the height of this cone is 13.1 centimeters. All right. So hopefully this video was helpful for you. For the remainder of today's class time, you're going to work on this assignment. And when I return tomorrow, so on Friday, you guys are going to have a quiz on topic 1.4. So during today's class time as well, I would like you to create a formula sheet that you think would help you solve questions related to these topics. All right, so please let me know if you need help with anything. I'll be more than happy to help. And I hope you all have a great day. See you tomorrow.